Hello students, welcome to Academy, the place for mathematics and science. Dear students, in today's class we are going to continue the chapter triangles. And do remember, this is second period of this chapter. In the very first period, we got the basic information about triangles, right? Just we shall go for recalling these one by one. Then after that, let's continue today's class. The first point is the definition of triangle. Yes, how do you define it? It is a geometrical figure bounded by three line segments, or a geometrical figure formed by joining any three non-collinear points is called a triangle, or a three-sided polygon is called a triangle, right? Then could you tell how many elements does a triangle have? Very good. There are 6 elements. Then what are these elements? They are 3 sides and 3 angles. We have different types of triangles. One based on the measurement of the angles, and second one based on the measurement of their sides. Then could you tell the triangle in which each angle is less than 90 degree? Very good. It is an acute angled triangle. Then what do you call a triangle in which one angle is 90 degree, exactly equal to 90 degree? It is a right angled triangle. Third one, a triangle in which an angle is more than 90 degree. What it is? This is obtuse angled triangle. Next, fourth one based on their sides. What do you call a triangle in which all sides are equal? It is equilateral triangle. And a triangle in which two sides are equal, this is called an isosceles triangle. And one more, a triangle in which all sides are unequal, this is called scaling triangle. Then one more type of triangle is there, which is the combination of both angles and sides. What do you call a right triangle in which two sides are equal? It is called isosceles right triangle, right? Isosceles right triangle. Then after that, we come across the different formula that we use to find out the area of the triangles. Then in general, first, the formula used to find out area of triangle, it is A equal to half into base into height. Then other than this, we use A equal to root 3 by 4 into A square for an equilateral triangle. Then we will also go for using one more formula, that is A equal to square root of S into S minus A, S minus B into S minus C, to find out the area of a triangle in which all the three sides are known. Then here what does S indicate? It is semi-perimeter. This can be written as A plus B plus C by 2, that is half of perimeter. Next, then we recall two important properties of triangles. What are these? Very good. One is angle sum property and second one is exterior angle property of triangle. Then what is the statement of first one? It is the sum of interior angles of a triangle is 180 degree. And the second one, if the side of a triangle is produced, then an exterior angle is formed, and this exterior angle is equal to the sum of its interior opposite angles, right? Then after all this, I introduced two important concepts. In one of the concepts, the geometrical figures having equal in all the respects. What it is? Yes, it is congruence, right? That is, and another one, a geometrical figures having the same shape but not necessarily in the same size. They are called similar. So these are the two important concepts. One is congruency, second one is similarity. We know the symbol for both. What is symbol for congruency? Yes, it is equal sign. Over that, we will go for writing horizontal 2. And similarity, just we write 3 vertical lines on the horizontal 2. Followed? Then after that, we focused on the concept called similarity. Now, could you tell definition of similar figures? Yes, two geometrical figures are said to be similar if they have same shape but not necessarily the same size. The sizes may be same or different. They are called similar figures. And this is also applicable to the geometrical figures which are bounded by only line segments. What they are? They are polygons. Then how do you define similar polygons? Yes, tell the definition. Polygons, two polygons having same number of sides are similar if and only if their corresponding angles are equal and their corresponding sides are in the same ratio, right? Next, after that, the important definition, that is similar triangles or similarity of triangles. So when you say two triangles are similar, yes, two triangles are similar if and only if first condition is their corresponding sides are equal and the second side, corresponding angles are equal, and the second point is the corresponding sides are in the same ratio. Is it not? Just I go for taking two triangles. Keep observing. This is the first triangle ABC, in which angle B is 90 degree. Let me take one more triangle and call it as PQR. In this, angle Q is 90 degree. Here, angle A, its corresponding angle is angle P. These two are equal. Angle C, its corresponding angle is R. They are equal. Assume that these two triangles are similar. If two triangles are similar, we know that the corresponding angles will be equal and the corresponding sides will be in the same ratio. Then how do you write that? Here, angle A equal to angle P. Then angle B equal to angle Q. Then angle C is equal to angle R. Right? Then corresponding sides, we write AB by PQ. This is equal to BC by QR is equal to AC by PR. If these two conditions are hold good, then we can say that triangle ABC is similar to triangle PQR. Yes. Dear students, here observing these two triangles, and with respect to these two triangles, I am going to take only this part. That is, in these two triangles, corresponding angles are equal. Then what do you call the two triangles in which the corresponding angles are equal? They are called equiangular triangles. Please do remember, equiangular triangles. Then with respect to an equiangular triangles, an important result was given by a great Greek mathematician, is Thales. That result is, in any two equiangular triangles, the corresponding sides will be in the same ratio. Followed? And it has been believed that Thales has used the basic proportionality theorem for that, the basic proportionality concept, and now it is also known as Thales theorem. Now let's go for proving Thales theorem. Dear students, please go for taking the definition of equiangular triangles, then this information. After writing up to here, then you can go for writing from here to here. See that here I have written a truth relating to equiangular triangles. just we have already come to know that the ratio of any two corresponding sides of equiangular triangles, it is always same. That is, when you consider ABC and PQ are two equiangular triangles, then look here, their corresponding sides AB and PQ, that ratio AB by PQ is equal to BC by QR, then that's equal to AC by PR. The same thing has been written, and this result or truth was given by a Greek mathematician Thales, and even we have believed that Thales used a result called basic proportionality theorem for this truth. Now we are moving to prove the basic proportionality theorem, familiarly known as BPT or Thales theorem. Yes, copy this one. Dear students, first we shall understand what is that basic proportionality theorem. Look here. Here I am going to draw a triangle, and you may name this as triangle ABC. Here how many sides are there? 3 sides. One is AB, second one is BC, third one is AC. Draw a line parallel to any one of these 3 sides. I take a line L parallel to BC, and this will intersect the remaining side AB and AC at 2 distinct points. Call these points as P and Q. Look here. This is the line, PQ is the line which is parallel to BC, and this line will divide AB and AC in the same ratio, that is AP by PB is equal to AQ by QC. This is basic proportionality theorem. Followed? Very simple. Look here, one side here. If PQ is parallel to BC, then AP by PB is equal to AQ by QC. But how do you make it as a statement? If a line is drawn parallel to a side of a triangle, then it divides other 2 sides proportionately. This is the statement of basic proportionality theorem or Thales theorem. Once I repeat, if a line is drawn parallel to any side of a triangle, then it divides other 2 sides proportionately. Clear? Yeah. Please go for writing the statement yourself. Dear students, please go for checking your writing. The statement is like this. If a line is drawn parallel to a side of a triangle, then it divides other 2 sides proportionately. Written up. And even you have to copy this. But how the question can be asked in the examination? Like this. First one. State and prove BPT, that is basic proportionality theorem. Or else, the question can also be given like this. Prove that if a line is drawn parallel to a side of a triangle, then it divides other 2 sides proportionately. These are the 2 possibilities. So, with question, let's go for proving this theorem. Right, this is theorem 6.1. BPT, nothing but Thales theorem. And the question is like this. State and prove BPT. First I have written the statement. If a line is drawn parallel to a side of a triangle, then it divides other 2 sides proportionately. Dear students, we all know that when we are proving a theorem, we follow some steps. They are, the first one is drawing appropriate geometrical figure. Second one is writing the given information is nothing but data. Third one is to prove. Fourth one is construction if necessary. Fifth one is proof, and the last one is conclusion. Yes, pausing the video, you can write up to here. After that, you can start writing with me. Okay. Now, could you tell what is the first step to be followed? Drawing appropriate geometrical figure. Then which geometrical figure should be drawn? Okay. If a line is drawn parallel to a side of a triangle, hence we have to draw a triangle. Please take scale and pencil and draw the triangle. Draw the triangle like this. And you can name the triangle as ABC, right? This is A, B and C. Now, let us draw a line parallel to BC which intersect AC at two distinct points. I name these points as P and Q. Look here, P is the point on AB and Q is the point on AC. Have you drawn? It has been clearly mentioned that PQ is parallel to BC, right? Only this much has been given. Go for writing the data. What we should write? In this triangle, in triangle ABC, what? PQ is drawn parallel to BC. Only this much is there. If it is there, now we are going to prove that what? It divides other two sides proportionately, which are AB and AC. They are to be divided into equal ratios. How do you write? AP by PB. AP by PB is equal to AQ by QC. Followed? Okay. Data is over, to prove is over. Next step is construction. Whether construction is necessary for this? Definitely. Then you all may be thinking that why? Look at AP and PB. AP and PB. No doubt, AP is the side of a triangle APQ. But PB, it should also be the side of a triangle. Hence, I go for joining BQ. Similarly, see that AQ is the side of the triangle APQ. Then QC, it should be the side of a triangle. Therefore, I will join CP. Got it? Next, but how to get this AP by PB? To get that, we should take the area of the triangle APQ and the area of the triangle BPQ. That is half into base into height. See that AP will be the base and PB will be the base. But what about the height? To get height, again we need the construction. So we have to draw the height of the triangle APQ. Hence, let us go for drawing perpendicular from Q to AP. You may call it as M. Followed. Next, again you draw perpendicular to AQ. To draw perpendicular to AQ, observe. See that we can go for drawing like this. Yeah. This is N. So PN is perpendicular to AQ. So this is the construction. Start writing this. Here, construction. Construction is draw QM perpendicular to AP and PN perpendicular to AQ. Draw QM perpendicular to AP and QN perpendicular, PN perpendicular to AQ. Also, what? We have to join PC and QB. Join PC and QB. Followed? Now, the next step is prove. How do you go for proving this? Very simple. I told you, we want to get these sides AP and PB, AQ and QC. Hence, I go for using area of triangle. What is area of triangle? Area of triangle is half into base into height. Now, let's go for using this. Here, AP and PB, they are the sides of two triangles. As they are in the ratio, I go for taking the same. that is area of triangle APQ and area of triangle BPQ. Here I'll write area of triangle APQ by area of triangle BPQ in these two triangles. See, first one, half into base into height with respect to APQ. Half into base. Base is AP. Height is QM. QM. Then area of BPQ. Half into base. Base is PB. And height is same only. Look here. This is an obtuse angle triangle. Hence height will be outside. This QM only. Right. QM. Now observe. QM get cancelled. Half get cancelled. You can call it as, you can write remaining AP by PB and call it as statement 1, not equation, statement 1. Anyhow, we got AP by PB on one side and other side AQ by QC is there. See this? AQ by QC. Hence again I should take the triangles. AQ is the side of APQ and QC is the side of CQP. Followed? Here I am writing area of triangle again APQ by area of triangle CQP. Triangle CQP. This is equal to half into base into height. Half into with respect to APQ. Base. No need to take again AAP. But because we want AQ. This time I am taking AQ as the base. If AQ is the base, then its perpendicular is PN. That will be the height. Here I will write PN. Then CQP half into base. Base is QC. And height is, again, it is obtuse, the height will be PN. Here also, PN and PN get cancelled, half and half get cancelled, remaining AQ by QC. Followed, you may call it as statement 2. Observe it. We are going to prove that AP by PB equal to AQ by QC. AP by PB and AQ by QC. If you want to prove these two as equal, obviously their LHS part should also be equal. And observe in the LHS part, we have area of APQ, area of APQ. In the denominator, BPQ, but here is CPQ. If BPQ and CQP are equal, then these RHS parts will be equal. Observe. BPQ, see that BPQ, this triangle, and CQP, this triangle. See that? What do you say about PQ and BC? These are the parallels. And these are the two triangles. They are standing on the same base, PQ. Between same parallels, PQ and BC. Hence, they are equal in area, which I have already learnt in 9th standard. Triangles standing on the same base between the same parallels are equal in area. Followed? So we can write the same thing. Here, we know that triangles on the same base and between the same parallels are equal in area. Triangles. Which are those two triangles? BPQ and CQP. BPQ, triangle BPQ and triangle CQP. Both are standing on the same base. What is that same base? PQ, right? Same base PQ, and between the same parallels, what are those? PQ and BC. They are the same parallels. Hence they are equal in area. So we can write like this. Area of BPQ equal to area of triangle CQP. You may call this as statement 3. Look here. When you substitute statement 3 in either 1 or 2, BPQ, it becomes CQP. Here also CQP. Both will be equal. Clear? Or else you may substitute here. In place of CQP, you may write BPQ. Then this ratio and this ratio, both will be equal. So these are the two things equal to the same thing. These are the two things equal to the same thing or equal to one another according to Euclid's axiom. Things which are equal to the same thing are equal to one another. Followed? So hence we can write from statement 1, 2, 3 and Euclid's axiom. Then look here, these LHS part will be equal, hence their RHS parts will also be equal. That is AB by PB is equal to AQ by QC. Followed? Hence it is proved. Very simple. You have to use the formula, that is area of triangle is half into base into height. Take the two triangles APQ and BPQ. Find out the ratio, you will get AP by PB. Next, you go for taking the triangle AQP, nothing but APQ and CQP, you will get the second ratio. And both the triangles are standing on the same base between same parallels, they are equal in area. Then by using statement 1, 2, 3 and Euclid's axiom, we can say AP by PB is equal to AQ by QC. Hence the theorem is proved. Got it? Please do learn this. It is important in the examination point of view. Copy this. Dear students, now we are moving to the reverse of BPT, nothing but converse of BPT. The theorem in which the data and to prove are interchanged, then we get a new statement that is called converse of the theorem. Look here, we have to state as well as prove the converse of BPT. Just we have learned BPT. What is that BPT? See that. If a line is drawn parallel to a side of a triangle, then it divides other two sides proportionately. That is AP by PB is equal to AQ by QC. Clear? Then what is its converse? If in a triangle, if a line is drawn to divide the two sides proportionately, that is in triangle ABC, I will take the line PQ. If AP by PB is equal to AQ by QC, then we have to prove that that line is parallel to the third side. Followed. This is the converse of BPT. Once I tell you, if a line is drawn to divide the two lines, if a line is drawn in a triangle to divide two sides proportionately, then it is parallel to the third side. Understood? Yes, please go for writing the statement yourself. Dear students, please go for checking the statement what you have written. If a line is drawn in a triangle to divide two sides proportionately, nothing but in the same ratio, then that line is parallel to the third side. Hope that you have written the same. Now, please take scale and pencil and draw the geometrical figure. Which geometrical figure? You are right, it is a triangle. Draw a triangle. Draw any triangle and you can go for naming the triangle as ABC. Right. This is triangle ABC. Have you written? Then let us go for drawing the line. We do not know whether it is parallel or not. We are going to prove it as parallel. call this line as PQ. Next, write data. What has been given? So, in the triangle ABC, they have given that PQ is a line, it is drawn and it will divide two sides proportionately. That means AP by PB equal to AQ by QC. AP by PB is equal to AQ by QC. Then what we are going to prove? We will prove that PQ is parallel to BC. So write to prove PQ parallel to BC. Then how do you go for proving? We do not know whether PQ is parallel to BC or not, which we are going to prove. Then if you assume PQ is not parallel to BC, then there must be a line parallel to BC, right? Hence I am going to assume, let us take the line. You may take Q dash or else here R, whatever you want. I'll take Q dash. Draw PQ dash parallel to BC. See, I am showing the symbol to represent parallel. Then here, construction. In construction, before constructing, first you have to assume let PQ is not parallel to BC. Then we have a chance of construction. What is that? Draw PQ dash parallel to BC. Followed? None. Please don't go for writing. From here, just keep observing. Now we are moving to the proof. Observing. Just we have come to know that PQ dash is parallel to BC. Then in a triangle, if whatever the line is drawn, if it is parallel to a side, then it divides other two sides proportionately. Right? Here I'll go for writing. In triangle ABC, PQ dash is parallel to BC. If it is parallel, we can go for applying basic proportionality theorem. Here I'll write by BPT. BPT we can write. How do you write? AP by PB equal to AQ dash by Q dash C. Here I'll write. AP by PB is equal to AQ dash by Q dash C. Now you may call this as statement 1 and this one as statement 2. Compare 1 and 2. Okay. Here in the LHS part AP by PB, here also AP by PB, but RHS parts are different. So these are the two things equal to the same thing are equal to one another according to Euclid's axiom. So we can write from statement 1 and statement 2 and Euclid's axiom. How do you write? It is AQ by QC is equal to AQ dash by Q dash C. Followed? Copy this. Written up. Next, look here. We have assumed that PQ dash is parallel to BC, but we are going to prove that PQ parallel to BC. If it is to be done so, then Q and Q dash must be coincide, right? Then how to do that? Very simple. Look here. AQ by QC is equal to AQ dash by Q dash C. We want Q and Q dash coincide. Hence, I go for adding 1 on either side. Adding 1 on both the sides. Why it is? You will come to know that. AQ by QC plus 1 is equal to AQ dash by Q dash C plus, followed. Then take LCM and simplify. Denominator QC as it is. Numerator AQ plus, multiply LCM with the second term. 1 into QC. It is QC. Here Q dash C is the LCM. Then we can write AQ dash plus Q dash C. Then just observe the geometrical figure, the drawn geometrical figure, and come and go through this. AQ plus QC. What is AQ plus QC? This is AC, right? So we can write AC by QC, which is equal to AQ dash plus Q dash C. AQ dash from here to here plus Q dash C. That is also AC, right? AC by Q dash C. Now AC and AC can be cancelled. What will remain? So it is QC equal to Q dash C. Look here. QC. The length of QC and the length of Q dash C, they are equal. Is it possible? No. But under what condition it is possible? These two are possible if and only if Q and Q dash coincide. Right? If these two are equal, we can say that the points Q and Q dash coincide. If they coincide, we all know that PQ parallel to BC and PQ will be equal, PQ dash is equal to PQ. Hence PQ will be parallel to BC. Understood? The points Q and Q dash coincide. We can write PQ is equal to PQ dash. And in construction we have written that PQ parallel to, PQ dash parallel to BC from construction. What is PQ dash? It is PQ is parallel to BC. Hence it is proved. Followed? Here I have written QED. What is the full form of QED? It is Code Errata Demonstrandum. The meaning of this is, hence the given statement is proved. Alright. Hence the theorem is proved. You may go for copying. From, I think you have written up to here, from here to here. Copy this quickly. Dear students, we have two important results of BPT, Basic Proportionality Theorem. We shall go for recalling that. You all know that what is BPT. In any triangle, if a line is drawn parallel to a side, then it divides other two sides proportionately, right? We write in this way. Here, if PQ parallel to BC, then how do you write? It is AP by PB, which is equal to AQ by QC, right? Then the results, two important results I told. Other than this, if PQ is parallel to BC, then we can write AP by the whole triangle AB. AP by AB is equal to AQ by AC. See that? AP by the whole side AB. AQ by the whole side AC. Next, one more. It is PB by AB. PB by AB is equal to only this part. QC by AC. QC by AC. Hope that you have understood. See that first term. AP by AB, AQ by AC. Next, PB by AB equal to QC by AC. Now we are going to prove these two important results that has been given in worked examples. Let me go for writing. And now you please copy up to here. Dear students, now we are moving to work example. In that, the first question is related to results of BPT. Okay. If a line is drawn to intersect AB and AC of triangle ABC at D and E respectively and is parallel to BC, then we have to prove that. Look here. AD by AB is equal to AE by AC. Just like this. AB by AB, AQ by AC. Then another one is DB by AB is equal to EC by AC. Followed? No doubt this will be very easier. Now I'll go for proving. Before that, pausing the video, you have to copy this. Then you can start writing with me. Hope that you have copied and start writing with me. Proof directly. Now we are going to prove first one. Look here. They have given that in triangle ABC, what has been given? DE parallel to BC. DE parallel to BC. If it is so, then which theorem can be applied? BPT, right? So we can write by basic proportionality theorem or Thales theorem. How do you go for writing? It is AD by DB equal to AE by AC. Right. AD by DB is equal to AE by EC. Followed? But what we are going to prove? We are going to prove that AD by AB equal to AE by AC. AD is there, AE is there. Don't disturb them, keep them as it is. Now, I go for writing them reciprocal. So that is DB by AD is equal to EC by AE. It is by reciprocals. Followed? You may be thinking that why should we go for taking reciprocals? Look here, we want AD as it is, AE as it is, and we need to take substitution for DB and DC as AB and AC. How to get that? By taking reciprocal and by adding 1. Look here, it becomes DB plus AD. What is DB plus AD? It will be AB. Then here EC plus AE, that is AC. Clear? Okay. Now adding 1 on both the sides. We can write DB by AD plus 1 is equal to EC by AE plus 1. Then take LCM and write DB plus AD is equal to AE is the LCM, EC plus AE. Followed? Then what is DB plus AD? DB plus AD is nothing but AD. AB by AD is equal to EC plus AE. EC plus AE is AC. AC by AE. Followed? But we want AD by AB equal to AE by AC. Hence, I go for taking again the reciprocals. So, by reciprocals, we can write AD by AB is equal to AE by AC. By reciprocals. Hence, it is proved. So, first one is over. Now, assume that second one has been given separately. Again, you will have to follow the same steps up to here. Look at it. This time we are going to prove that DB by AB equal to EC by AC. Again, you should write in triangle ABC, we know that DE parallel to BC. Written. If a line drawn is parallel to a side, then it divides other two sides proportionately according to basic proportionality theorem. We can write AD by DB is equal to AE by EC. But what is required? DB by AB, EC by AC. DB is already here. EC is already here. We want substitution for this. Hence, we should add DB to this, EC to this. Hence, let us go for adding 1 on both the sides. How do you write? It is AD by DB plus 1 is equal to AE by EC plus 1. Then DB is the LCM. You will get AD plus DB. Next here, EC is the LCM. You will get AE plus EC. Right? What is the sum of these two? AD plus DB? AD plus DB is AB. AB by DB is equal to AE plus EC. It is AC. AC by EC. DB by AB, EC by AC. Hence, we shall go for taking reciprocal. By reciprocals, we can write DB by AB is equal to EC by AC. Go to that. Hence, it is proved. Hope that you have understood. Please do practice. See that the first we have discussed about BPT. We have proved it. That's an important theorem. Chance of giving that in the examination. Next, converse of BPT. Now, third one is results of BPT. These results have been given in worked examples. We have written both of them. Now we are moving to next one. Just put star mark for this and copy. Okay, students, this is another important statement. Putting star mark, you may go for copying this. Then after that, you can start writing with me. Yes. Hope that you have written. Now, write. First data. What has been given? ABCD is a trapezium. Here I write in trapezium. In trapezium, ABCD. What has been given? AB parallel to DC. AB parallel to DC. Not only that, even EF is parallel to AB. EF parallel to AB. This much. With this information, we are going to prove that those parts, the non-parallel sides. Okay. A and F are the points on non-parallel sides AD and BC respectively. Then we should prove AE by ED is equal to BF by FC. Prove. Look here. How do you go for proving? So far we have learned the concept called BPT or converse of BPT or results of BPT with respect to triangle only. But is there any triangle? No. Hence we need to take triangle. That is why we can go for construction. Okay. You are going to prove that AE by ED equal to BF by FC. AE by ED. That hence I go for joining AC. This intersect EF at G. Look here. Then we know that EF parallel to DC. Hence, these two sides will be in the same ratio. Clear? In the same way, here in this triangle, GF is parallel to AB. Hence, these two sides are the ratio of these two. BF by FC is equal to AG by GC. On comparing both, we can write these two ratios are equal. Hope that you have understood. Yes, start writing with me. Construction. Construction is join AC. Join AC which intersects EF at G. Followed. Next, proof. Right. I go for taking the triangle ADC. In triangle ADC, can we write EG parallel to DC? You may be thinking that, sir, it has not been given. No doubt. But they have given EF parallel to AB, and we also know that AB parallel to DC. So because AB parallel to DC, the reason is AB parallel to EF. Clear? In triangle, if a line drawn is parallel to a side, then it divides other two sides proportionately. We can write AE by ED. AE by ED is equal to AG by GC. AG by GC. Call this as statement 1. It has been written from BPT, Basic Proportionality Theorem. Similarly, this time we want these two. Hence, I go for taking the triangle ABC. In triangle ABC, we can write GF is parallel to AB. GF parallel to AB. The reason is, we know that GF is a part of EF, which is parallel to AB. We can write EF parallel to AB. If it is in a triangle, if a line is drawn parallel to a side, then it divides other two sides proportionately. So by BPT, how do you write? Usually we go for taking in this way. CF by FB is equal to CG by GA. That is also equal to BF by FC is equal to AG by GC. Here I'll write BF by FC is equal to AG by GC. Let us call this as statement 2. Observe. In statement 1 and 2, you can come to know that AG by GC, here also AG by GC. And AE by ED, BF by FC. These are the two things which are equal to the same thing, hence are equal to one another. So we can write from statements 1 and 2 and Euclid's axiom. Euclid's axiom we can write AE by ED is equal to BF by FC. So hence it is proved. It is proved. Clear? Go for copy. Yes, students, please go through this third one. No doubt it is simple one. The statement is like this. In this figure, here they are given the triangle PQR and ST is a line, and we have got two equal angles. See that angle PST equal to PRQ they have given, and PS by SQ is equal to PT by TR. If it is so, we have to prove this as an isosceles triangle. Is it not simple? Definitely it is as simple. Then we have already come to know what is an isosceles triangle. What is that? A triangle in which two sides are equal is called an isosceles triangle. Even the isosceles triangle property as well. That is, the sides opposite to equal angles of a triangle are equal, or the angles opposite to equal sides of a triangle are equal. Let's go for using that. Here I'll go for writing the proof directly. Here they have given the triangle PQR. In triangle PQR, what has been given? See that PS by SQ is equal to PT by TR. PS by SQ is equal to PT by TR. So we can just recall one statement that a line is drawn in a triangle to divide two sides proportionately, then that line is parallel to what? Third side. Which is that? It is converse of BPT. Here I'll write by converse of basic proportionality theorem. How do you write? ST is parallel to QR. It is very important statement, so that I am highlighting this. Next, it has been given that these two angles are equal, which are angle PST and PRQ. I go for numbering the angles. They have given angle 1 and 2 are equal. Here I'll write angle 1 equal to angle 2. Reason, it is from dot. But we have to prove PQR is an isosceles triangle. That means two sides should be equal. If you want to prove two sides as equal, their opposite angles should also be equal. That means Q and R. Dear students, just we have come to know ST is parallel to QR. If ST is parallel to QR, what do you call PQ which intersect these two lines? It is a transversal, right? If it is a transversal, what do you call the angles formed on the same side of the transversal at distinct points on the same sides of the parallels? They are called corresponding angles. Then can you say that angle 1 and 3 are equal? Very good, you are right. It is angle 1 is equal to angle 3. The reason is corresponding angles. Instead of taking 3 letters, I have given the numbers. It will be easier. Angle 1 equal to 2 and it has been given in the information. And angle 1 equal to 3, they are corresponding angles. Okay. These are the two things equal to the same thing or equal to one another. So angle 2 is equal to angle 3. The reason, it is from Euclid's axiom. Which is that things which are equal to the same thing are equal to one another. If angle 2 and 3 are equal, their opposite sides will be equal, right? We can write angle 2, its opposite side is PQ, 3, opposite side is PR. PQ is equal to PR. The reason, sides opposite to equal angles of a triangle are equal. Sides opposite to equal angles of a triangle. If PQ equal to PR, when two sides are equal, then we can call it as an isosceles triangle. Therefore, PQR is an isosceles triangle. Dear students, in the very first period only, I have given the different types of triangles. Please, you should be thorough about those basic concepts, because in between the chapters often we will go for using them. I hope that you have understood this. Now, please copy this one. Dear students, now we are moving to solve the problems given in exercise number 6.1. In the very first problem, they have given two figures. One is triangle ABC, and in both the figures, ABC is a triangle and D is parallel to BC. If it is so, and we have to find out EC, look at this part. In first one, and AD, this is the part in second one. Is it not simple? No doubt. Look here, as D parallel to BC, which theorem should be applied? BPT, basic proportionality theorem. Then 1.5 by 3 is equal to 1 by this unknown term, right? We can simplify that. There also we can follow the same thing. So pausing the video, you should copy. Then after copying, start writing with it. Yes, it is. Now we are moving to the first one. In first figure, in figure 1, that is triangle ABC. In triangle ABC, they have given DE parallel to BC. DE parallel to BC. So by basic proportionality theorem, you can write AD by DB equal to AE by EC. AD by DB is equal to AE by EC. Even you can take the substitution directly. What is AD? AD is 1.5, DB is 3. So it is 1.5 by 3 is equal to AE. AE is 1 by EC. Then here it is, you can cancel 1.5 ones are 1.5, 2's are. It is 1 by EC. Then cross multiply. EC is equal to 2 centimeter. Is it not simple? Chance of giving this in the examination for 1 mark. Next, second one. Come across the figure second one. There also same thing. In triangle ABC, they have given D parallel to BC. Right? Then go for writing. AD by DB is equal to AE by EC. Substitute. What is AD? It is unknown. By DB. DB is 7.2. Which is equal to AE is 1.8 centimeter and EC is 5.4 centimeter. You can cancel it directly, or else you can do one thing. AD by 7.2 as it is. Here, these are in decimal. After the decimal, we have one digit in both numerator and denominator. Hence, we can write 18 by 54. Cancel it. 1s are, 3s are. 18 ones are, 18 twos are 36, 18 threes are 54. Then AD is equal to cross multiply 7.2 by 3. Then AD is equal to, cancel it, 3, 2s are 6, 1 will remain, it becomes 12, 3 4s are. AD equal to 2.4 centimeter. Conclusion. Therefore, EC is 2 centimeter and AD is 2.4 centimeter. Got it? Go for copying this. Dear students, please go through second one. This is also very simple. The statement is like this. E and F are points on the sides PQ and PR respectively of triangle PQR. Just for your reference only, I am drawing the triangle. It is PQR. E and F are the points on the sides PQ and PR. Let us join. Then for each of the following cases, state whether EF parallel to QR. How is this? When you say EF is parallel to QR or the line drawn in a triangle is parallel to a side, it is possible if and only if the respective ratios are equal. That is, if PE by EQ equal to PF by FR, then only the lines will be parallel according to converse of BPT. Yes. Now here they have given 3 statements. Let us go further. Pausing the video, you can copy from here to here. For your reference, you can draw the figure. Yes. Let us verify that. Here I am writing verification. They have given P 3.9, P 3.9, then EQ 3. So first we can find out PE by EQ. PE 3.9 by 3. How much it will be? It is 1s are, 3s are. Right. Next we want PF by FR. PF by FR. What is PF? It is 3.6. And FR, it is 2.4. After decimal, one digit. So you can write it directly. 36 by 24. Cancel it. 12 2s are 24. 12 3s are 36. This will be 1.5. Whether these two ratios are equal? No. Hence EF is not parallel to QR. Understood? Write down. Here we can write PE by EQ is not equal to PF by FR. Therefore, EF is not parallel to QR. Or else even you can write that in words. EF is not parallel to QR. First one is over. Now let's move on to second one. Again, verification. Copy this. P equal to 4 centimeter. This is 4. QE 4.5. 4.5. PF 8. It is 8. Then RF it is 9. Yes, let's go for finding. Right. Verification. Find out the ratio. First one is PE by EQ. It is 4. 4 by 4.5. This can be written as it is 40 by 45. Because after decimal, one digit in the denominator. To remove this, you take 1 0. It is 40 by 45. Cancel it. Both are divisible by 9. Sorry, 5. 5, 8s are 45, 9s are 45. Then second ratio, PF by FR. This is 8 by 9. Compare. 8 by 9, 8 by 9. Both the ratios are equal. Here I write PE by F, P by EQ is equal to PF by FR. Therefore, we can write EF by converse of BPD, we can write EF parallel to QR. Got it? Next, third one, PQ 1.8. See that from here to here, 1.28. Next, PR 2.56. From here to here, 2.56. PE 0.18. 0.18. Then PF, it is 0.36. Now we have to find out that. Yes, right. Verification. This is also very simple one. Let's go for finding the ratios. The ratios are PE by EQ. What is PE? It is 0.18. What about EQ? Have they given EQ? No. But EQ can be found out by subtracting 0.18 in 1.8. See that from here to here 1.28. In that subtract 0.18. 1.28 minus 0.18. Now this is equal to 0.18 divided by, now 1 minus 1.28 minus 0.18 is 1.10. See, 8 minus 8, 0. 2 minus 1, 1. Then 1 minus 0, 1. This is equal to 18 by 110. Cancel it. It is 2 9s are 2, 55s are 9 by 55. Hope that you have understood. Next, I'll take PF by FR. What is PF? It is 0.36. FR, how do you get? 2.56 minus 0.36. It is equal to 0.36 by, subtract 6 minus 6, 0, 5 minus 3, 2, 2 minus 0, 2, 2.20. It is equal to 36 by 220. Then cancel it by 4, because the number formed by last two digits are divisible by 3. Sorry, 4. 4 9s are, then this is 4 5s are 20. 2 will remain. Again 20. 4 5s are. See that? 9 by 55, 9 by 55. Both the ratios are equal. Here I write PE by EQ is equal to PF by FR by converse of BPT. What you can write? We can write EF parallel to QR. Understood? Yes. Go for copying this. Dear students, this is also one of the important statements and is also very simple. Pausing the video, you may copy this. Then after that, I'll explain. Yes. Hope that you have copied and observe it. In this figure, they have given LM parallel to CB. See that I am marking LM parallel to CB. And LN parallel to CD. If it is so, we have to prove that AM by AB is equal to AN by AD. Is it not simple? Definitely. The reason is Here we have parallel lines, then we have triangles. Hence, we can go for using BPT. And more than that, see that AL and LC or else AC, it is a common. That's why we find it easier for proving. Go for writing with me. Prove. Prove. First, I go for taking ABC triangle. In triangle ABC, what has been given? LM parallel to CD. LM parallel to CB. If LM parallel to CB, then according to BPT, basic proportionality theorem, how to write? AM by MB. AM by MB is equal to AL by LC. But we are going to prove that AM by AB. AB is not there. Never mind. Here common side is there. Here just go for continuing this. You may call it as statement 1. Next. Take another triangle. What is that? ADC. In triangle ADC, it is LN parallel to CD. LN parallel to CD. If it is so, we can write AN by ND. AN by ND is equal to AL by LC. AL by LC. You can call it as statement 2. See that? In both the statements, AL by LC, AL by LC. And these are the two different things, equal to the same thing, or equal to one another. According to what? Very good. According to Euclid's axiom. Here I'll write from statement 1 and 2 and Euclid's axiom. Axiom. How do you write? AM by MB is equal to AN by NB. But you can notice that AM by AB is equal to AN by AD. This is the statement to be proved. But here AM and AN are there, but there is no AB and AD. To get AB, see that AB it is AM and BM. AM is there, we want BM. So it should be added. Hence I go for taking reciprocals. By reciprocals, how do you write? We can write it as MB by AM is equal to NB by AN. Followed? Keep that AM as it is. As we need AB, let us go for adding AM to the numerator, AN to the numerator. How? By adding 1 on both the sides. Dear students, hope that you are remembering where we have used the same concept in proving the results of BPT, right? So here adding 1 on both the sides, then we can write MB by AM plus 1 is equal to ND by AN plus 1. Then AM is the LCM, numerator MB plus AM. Here denominator LCM is same, AN, and this is ND plus AN. What is NB plus AM? MB plus AM. It is AB. AB by AM is equal to ND plus AN. ND plus AN. It is AD. So AD by AN. We want AM by AB, but here AB by AM. What you will do? Again by taking the reciprocals. By reciprocals, we can write AM by AB is equal to AN by AB. See that it has been proved. Followed? Please go for copying. Dear students, hope that you have written up to here, and this statement to be proved is, which has been proved, is very simple. Please do practice. And particularly in today's class, we have moved on to the actual concept. The first one is basic proportionality theorem. Second one is converse of basic proportionality theorem. Third one is results of basic proportionality theorem, which are also called corollaries of BPT. Along with that, we have solved some of the worked examples, and in exercise 6.1, 3 are over. But all the problems, all the statements what we have proved today, they are very important in the examination point of view. Please do practice them today itself without fail, particularly the theorems. So with this, let us stop the class. Thank you very much.